Hello everyone, let's start with another exercise. Exercise 1.4. It says without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating decimal expansion. So now here we have one theorem that relates to it. So whenever we are given with a rational number that is p over q, it must be equal to p over q and p must be equal to co-prime, p and q must be co-prime. Then it says that if we have a q, the denominator must be in the form of 2 raised to power m into 5 raised to power n. It must have a factor of 2 raised to power m and 5 raised to power n. Now let's see the first one. In the first one we have 13 over 3125. Now 13 over 3125. Now we can write q that is denominator is 3125 equals 5 raised to power 5. Now we can write here multiply times or into 2 raised to power 0. So m is 0, n is 5. Now therefore we can say it is a terminating decimal expansion. So this is a terminating one. Whenever we have a form of 2 raised to power m into 5 raised to power n, it will be a terminating. If it is in the form of 2m raised to power 5n, therefore we can say that they are non-terminating. Now the second one, 8. 8 is there. 8 can be written in the form of 2 raised to power 3 and 2 raised to power 3 into 5 raised to power 0, because 5 raised to power 0 is 1 and every number has a factor 1. So therefore this is terminating again. Now moving on to another one, it is 455. Now 455 can be written in the form of 5 into 91. This will be non-terminating because the denominator is not in the form of 2 raised to power m into 5 raised to power n. So this is non-terminating. Now fourth one we have 1600. 1600 can be written as 2 raised to power 6 into 5 raised to power 1. So this is equal to 1600. So this can be written in the form of terminating. Now the fifth one we have is 29 over 343. 343 can be written in the form of 7 raised to power 3. Now we don't have number like 2 and 5. So therefore it is non-terminating. Now next one is the simplest one. It has 2 raised to power 3, 5 raised to power 2. So therefore you can write it as terminating. Now the seventh one, 129 over 2 raised to power 2, 5 raised to power 7 and 7 raised to power 5. Now we can see that one is extra, that is 7 raised to power 5. So it will be non-terminating because it has extra number, that is 7 raised to power 5. Now the next one we have is 6 over 15. Let us simplify this. This can be written as 2 over 5. Now we can see that it has a factor of 5 at the bottom. So therefore we can say that it is a terminating decimal expansion. Now the next one we have is 35 over 50. 35 over 50 can be written as 7 over 10 and 10 can be written as 2 into 5. So therefore it is a terminating again. Now the 10th part we have is 77 over 210. So it can be simplified first. It is 11 over 30. So we have 30. Factor of 30 are 3 into 5 into 2. So therefore non-terminating because there is one extra factor to it. So this is question number 1. Thank you for watching this.